Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, background checking your open source with Michael Mehlberg, CEO of Dark Sky Technologies. Michael, welcome to the show.
Thank you for having me.
Hey, Michael, when we first talked, I was really enamored with what you guys do, which we'll get to in a second. But first off, I know my audience wants to know a little bit more about you and where you come from and what you're doing now.
Yeah, happy to share. I've been in technology for as long as I can remember. Started when I was about 12 years old. I had a friend that was working on a compact computer, which is kind of a compact with a Q, if you remember that.
I remember that. Oh, yeah.
It's a funny name because this thing was huge. It had a handle on the back, but it probably weighed 50 pounds.
But you could carry it around. It was compact, right? I remember that.
Exactly right. And he had programmed this game. I think he called it Immortal Combat. There were two stick figures that were fighting each other, and I was just floored that you could do that. I never thought about where programs came from. And so I started programming. He helped me learn. I started programming, and I knew right then I was going to get into software development, so making video games all through high school, and then finally ended up at Purdue University studying computer science, and left there to go right into industry, where I was working on basically DoD software protecting weapon systems against tampering and reverse engineering. So I got a crash course on how to reverse engineer software at the first company I did an internship with. And I love solving problems. It turned out to be at least good enough to keep my job there. And from there, just, got into the whole industry and protecting software, protecting weapon systems, and have been, learning ever since. And I'm still learning. Cybersecurity is one of those things that it's kind of a never ending job. There's always some new attack out there and some new way to defend against it.
Well, it does keep us actually busy, right? It keeps us employed, right? So yeah. I guess we attribute it, we like the hackers out there causing us to have? No, probably not. There's plenty of other problems to solve without them creating more, right?
Yeah, very much so.
So tell me a little bit about when I first talked to you. I went, wow, I never thought of this, about the whole open source. There's a big push right now on securing the software supply chain out there. Open source is a big aspect of that. Tell me your guys' approach to helping secure the software supply chain.
Yeah, I guess it would help to see what I've seen over the past 20 or so years. When I first got started, we were really just focused on protecting operating system, or even applications, right? Just a single application. If it had some data in it or some algorithm that was particularly sensitive, we wanted to protect it, because if an attacker got hands on, then, they would understand it, or they would be able to reveal, the secrets that were in the software. And so we started with just applications, started then protecting bigger systems, right? Operating systems and things of that nature. And over time, the open source development community just started exploding. And so while we were learning, how to both break into and defend systems, there were just thousands and thousands of packages being put out there by the whole open source community, which was phenomenal, because first thing you do as a developer is you go looking for, somebody who's already solved the problem, so that you don't have to reinvent the wheel. So eventually, it came to a point where, all right, there's a lot of operating systems out there. There's constantly problems within operating systems. How do you really make a secure one, right? You can patch all this stuff on after the fact. But what if you miss something, right? It's a tough game, a cat and mouse game that we play with the attacker. And unfortunately, it's in the attacker's favor most of the time, because we have to get we have to catch every single bug and every vulnerability in order to protect the system wholly, which is an impossible task most of the time. Whereas an attacker only has to find one.
They only have to find
problem.
one. Yeah.
Yeah. And then they're in. So how do you really make a secure system from the ground up? Well, everybody's using open source. A couple of years ago, Linux is huge. It's in every system that's out there just about. And but how do you secure it from the ground up? And we kind of came to this realization that, boy, if we can't trust the developers who are developing the software, that's kind of the foundation of it, right? Is we trust our developers, then how do we actually trust the code that we would want to use from all of these different open source packages? And so that's kind of how we, I guess, came to where we are today, first starting on embedded systems security, just focused on the application, then kind of broadening our view to how do we secure the whole operating system. And now we're really looking at kind of fundamental trust issues. And when I first started, software supply chain, I don't think was uttered once in any conversation that we had. And only recently, right, have people really started talking about it. And I think it's just because there truly is a software supply chain now. There are, just an enormous number of packages and developers out there that are all contributing both from within organizations and without organizations, creating this supply chain of people who develop systems, in some cases unknowingly, right? They're just developing a package elsewhere in the world. They have no idea that it's being used in really critical systems.
Well, so that brings up something interesting that you said. You have to trust your developers, right? Mm-hmm. So typically, I know when I got hired on at my first job, oh my goodness, the vetting that they did for me was outrageous, right? I had psychological profile done. I had background checks. I had security checks done, all this stuff, so that the company knew who they were bringing in and writing software. And specifically for me, it was for medical imaging was my first job out of college. So they were ultra cautious. But we just go and download some open source package off the internet, right? We don't know who wrote that stuff. We have no idea if they have a bent towards doing something malicious or nefarious.
Sure. I mean, we go to great lengths to trust the people that we bring into our organizations. And then, I have development background. What's the first thing you do is you go and try and find somebody who's already done it, and they are probably not inside your organization. They
probably not. Yep.
Probably haven't been checked or looked at. And 99 point whatever percent of those people are probably developing open source for the right reasons. They're putting their code out there. They're sharing it. That's the amazing aspect of it. But there's also kind of, the few that can ruin it for the rest of us. And you don't know, you just don't know what you're getting because you haven't put anybody through that type of process.
So is that why you guys kind of shifted your focus from protecting embedded systems to operating to systems to getting down to the core, which is, can I trust the person actually writing the code? Is that why you got to that?
Yeah, it really is, because still the ultimate focus is getting a system out there that is secure and, accomplishes whatever mission that it needs to accomplish. But as we're building it, because we're pulling in from all of these different places, software packages, left, right, up and down from all over the world, boy, if we can't trust those, and our assertion is that you can't, because you don't know who has worked on it. You got to at least look at it and make sure that you're not pulling in, a problem, either an intentional or a maliciously inserted problem into, what are really, really critical systems to either, national security or economics or whatever it may be.
Well, I mean, when people argue, well, I test the software, right? I've tested the software. It passes all of the tests that I run to make sure there are no vulnerabilities or anything like that. Or maybe you do a code review. Do you go line by line on open source code? I don't know very many people that do. No,
I don't. We talked about that a lot, and in so many cases, you just can't. I mean, the Linux kernel alone has it's maybe exceeded 30 million lines of code.
That's amazing.
At this point. And if you have an enterprise distribution, something like Red Hat, you're talking about 100 million lines of code or more. It's just untenable to review all of that, with human beings at least. So you apply tools to it to try and see if you can catch vulnerabilities. And those tools, they still have to remain in our pipelines.
So we're not getting rid of those tools. We still need those tools.
Absolutely. Yeah. If, we can identify so many past vulnerabilities, we don't want to see them again, right? As a developer, you copy and paste code. You may unintentionally copy a vulnerability that's already been detected in one package and you're using it over here in another. A software assurance tool ought to be able to identify that immediately and root it out.
So then why even care about who's contributing if these tools out there are looking at things? What danger is there in having a developer that's malicious if I'm scanning their code anyway?
Yeah. So the trouble is, I don't know the latest numbers off the top of my head, but there's some dozens of new vulnerabilities that are discovered every single day, right? And so that tells me, and tells kind of the cybersecurity community of experts that there's something that we're not catching. There's something that's in there, that's getting in there, that we're not able to identify up front. Because if we could identify it up front, we would root those out, and you'd see zero new CVEs.
Right. Yeah. You're right.
There's also, some more nefarious things that could happen. Switches that get flipped at the behest of some attacker, where you don't know if there's any kind of malicious code in there until that switch is flipped, until they've
like a runtime switch, even. Yeah,
something like that. I think those are probably going to be few and far between, but these are the creative things that you can do as an attacker to try and inject malicious code. I think the real point is, if you don't know where that code is coming from, which you don't if you're just grabbing it from anywhere, then you don't really know what you're pulling in. And given that there are so many new vulnerabilities every day, given that there are millions and millions of developers out there we just don't know anything about, and some very small percentage of them that can kind of upset the apple cart for the rest of us, it's worth taking a look to make sure that a package that you pull in doesn't have something that was injected maliciously.
So you said something interesting. There's a bunch of us that depend on a small number of packages that could affect lots of things. Log4j is a great example, right? When the Log4j vulnerability came out, right. There was another package, and I can't remember the name off the top of my head, in the Node.js community that almost everyone depended on, either directly or indirectly depended on.
Sure.
That was maintained by one person.
Right. There's quite a few of those, actually.
Yeah. So, whoa. When you think, and it popped up because this one person was like, everyone's making money off of me. Where's my take?
That happens a lot. I even used to think of open source. You think of open source as a community of people that are all eyes on this one package, and you're going to have security experts in there, as well as programming experts and memory experts, and they're all going to point out, when you put this package out there in the open, they're going to point out where the problems are. Hey, you're using memory wrong over here. Hey, this is a vulnerability that we've already seen before. Don't program it that way. At the end of the day, a huge percentage of packages are really being developed and maintained by just one, or in some cases, a handful of people. there's big packages for sure, like OpenSSL, a crypto package being developed by hundreds of developers, or the Open Java Development Kit, I think, has some 600 plus active developers. But most packages, and when I say most, I mean a double-digit large percentage of packages are maintained by one
or two people. Is that something? Yeah. Is that something that? Well, obviously, we're concerned about. Is that something that you can easily identify?
Yeah, most of the time that information is available. Who is actively contributing to it?
You just go on GitHub most of the time, right, or GitLab or wherever they're hosted.
Yeah, that's there and available. And even who is inactive, meaning they've contributed in the past and they are no longer making contributions. And so all of those can be kind of interesting pieces of data that you can see a timeline of history. You can start to understand how supported or unsupported a particular package is, and that may be a risk for your program if you have a really critical program that you're working on, and you have this one piece of software, no matter how small, that is just a critical piece to that Jenga stack of blocks that you have in your entire software stack. You don't want that thing falling out from under you and causing the rest of it to topple. So it's worth knowing how supported it is. It's worth knowing a little bit about where it comes from and who's worked on it.
That I just on who's worked on it too. You could, because I know there's developers out there, contributors to open source, that work on similar packages at the lower levels or framework levels, and these are very prolific programmers that work across several different packages at the same time.
Sure.
Right, and they're contributing. I think it would be fascinating to take a software package and break it down and see the number of contributors you have on open source, and then see who your biggest contributor is of the full software stack by number of packages or lines of code, whatever. I think that would be fascinating to look at, because you could easily see who you're mostly dependent on, an individual.
That's right.
Right?
That's right. Yeah, some when you say prolific, some people are. We have visualizations that we've created by looking at this in different ways that show some people are making tens of thousands, or in some cases hundreds of thousands of contributions. It could be something as small as a change to a character in a line of code, or something as big as a check-in of a function, but tens of thousands of changes, additions, or removals to open source packages. They really truly are prolific, and it's fascinating to see how the whole community kind of comes together, and then certain people who are they're kind of the whales for a particular package are really influencing things.
Wow, that's now here's another question. What motivates? Because there's some motivation behind developer. I'm a software developer too, Michael, so and I've contributed to open source. What's that motivation for someone to spend that much time and effort?
Boy, I mean, I can speak from experience. Is when I get a problem, a technical problem that I can solve with programming, I just can't stop until I solve it, and I think that's part of it. There's definitely a tremendous feeling of satisfaction that you get from open source and contributing back to the community by seeing a lot of people use the package that you've created.
Yeah, you're right. When I've written a package or something and the number goes above 10,000, you're like, yes, look how cool I am, right? It's like, exactly. I'm contributing to society, right? People are downloading my stuff. It's awesome.
That's right. There's the unfortunate side of it. That very same, I think that very same set of motivations can also contribute to the attacker side of things as well, where, oh, look at this log4j, for example, you mentioned earlier, millions and millions of instances of that package out there in the wild. I bet they were head over heels happy about how widely spread that particular vulnerability was. So in fixing it, was one of the most important things that we did quickly because of how widespread that was.
Yeah, that's crazy. So tell me a little bit about what dark sky technology is doing in this space, because we kind of touched a little bit on it. So if I wanted your guys' services, what sort of help could you give me to see my open source vulnerabilities? I'm going to call it, maybe it's not vulnerabilities, maybe it's exposure.
Yeah.
Right.
Yeah, really a risk or a measurement of trust.
Measurement of trust. I like that even better.
Yeah. That's maybe best illustrated with an example. There was a package last year. You can look it up. There was a Reuters article that came out about this package called Pushwhoosh. And Pushwhoosh is kind of a sophisticated notification package. If you wanted to put notifications in an application that you were developing, and you didn't want to do that yourself, you could integrate Pushwhoosh in there. Well, the Army and the CDC had integrated Pushwhoosh into multiple applications. I think the CDC had said 7 or 8 that they had put it in. Not sure how many for the Army, but they had put this in there and they were using it. And by the looks of it, Pushwhoosh was an American company. They were, American run, headquartered, I think, in California, with offices in Maryland and somewhere else in the United States. Come to find out, they were actually not headquartered in America. They were headquartered in Moscow. They were paying taxes in Moscow. They had developers in Siberia and some in Thailand as well. And so you don't even have to know if there is a single vulnerability in that package to immediately know that you want to remove it from the applications that are in your systems and software. And that's what the Army and the CDC did, is they removed it. And that was what led to that Reuters article. Holy smokes, right? There's potentially Russian influence in our applications that we had to get rid of because of this.
Well, that's really interesting, because I could see this is the open source community could be easily infiltrated by nation state bad actors.
Sure.
And we all know some of the best programmers in the world are coming out of Russia, Estonia. They've got great programmers in that area. So I would guess that they are contributing to open source.
Yeah, I think it's safe to say that any avenue that a foreign state actor could use to infiltrate or get some sort of meaningful advantage over technology, that they're going to do it. They're going to leverage. You have to assume that, right? That's the game that you play. So Pushwhoosh, the first thing that we did when we saw that article is that we plugged it into our own tools, because a lot of the tools that we've developed are aimed at automatically detecting trust issues like that. And so we plugged it in, tools went out, did their analysis. They looked at different sources of intelligence that are out there, open sources of intelligence, and made a determination that, holy smokes, there is an enormous effort inside of Russia to develop this particular Pushwhoosh application or package. And there is no development out of the United States. And so that's a red flag. Right away, you're telling me you're an American company, but you don't have a single, piece of development happening out of there. So it was able to detect sort of trust issues like that and raise a warning flag and say, hey, not so sure about this. Open source is developed all over the world. It doesn't mean there's anything wrong with it. There's, like you said, there's plenty of very good Russian developers or any nationality for that matter who are contributing to open source. But when you say you're one thing and you're actually another,
that's an issue.
That's potentially.
So what other trust issues do you guys evaluate? I mean, location. Of course, location is going to be built into that trust, whether we like it or not, right? Mm-hmm. The federal Department of Defense is not going to use open source that was developed in China or Russia right now, or North Korea.
Sure.
They're just not. right?
Right.
So that's one trusted. What other do you score? Do you how do you evaluate a contributor?
It's really quite difficult, and we in fact do not want to be in the business of scoring, because every program is going to be a little bit different, right?
Okay.
You're going to have there's going to be some absolute no's, right? If you have a developer from a sanctioned company or country,
Yeah.
I want to flag on that right away. The rest of it, though, can be quite a bit, gray, so to say. You've got some programs that are going to say absolutely no to this country, having any development influence, or absolutely no to this company having any sort of development influence. And you've got other programs that, they don't care. They're not as sensitive. And so it really is up to the program or the business unit or the company itself to determine what their business and security requirements are. I think the government is coming around. You've probably seen recently with the executive order and the follow-up memorandum about software bill of materials.
Yep.
There's really a push for software supply chain security. And in that memorandum, they even mention having a risk framework. And it wasn't particularly well defined what that risk framework is. I think we're going to get to a nice definition here, in the coming months or year. Once that definition happens, we might be able to say, all right, there's some quantitative things that we can do here to alert ourselves if we run into these issues. This country is a no. Somebody who's contributed multiple CVEs is a no.
Yeah, I was going to ask that. I mean, so what attributes can you report on? Not necessarily scoring, but you are reporting on attributes like this guy contributed or this programmer contributed and it resulted in a CVE. And that happens a lot. Mm. Like if you ran it on me, it might say, Darren has a 25%, CVE generator, right? I'm a CVE generator. That would be bad, right? I don't want to use any of his code anymore because he writes crappy code, right?
Right.
So can you get down to that level where I can look at, correlation between Darren checking in code into open source and CVEs coming up on his code, right? I mean, you can get down to that level.
I don't know if there's anybody out there doing it, but multiple CVEs would certainly be a flag.
A flag.
And again, that may be intentional or not intentional, right? So, like I said, you copy paste code all the time. If there's a piece of code you're using over and over again,
a ChatGPT wrote it for me. That's what I'm going to plug.
Yeah. That's right. It wasn't my fault.
It wasn't my fault. ChatGPT did it. What about going beyond just programming, right? What about looking in, because they do this, they do this all the time with employees. They look at financial records. They look at, right?
Mm-hmm. Yeah.
I don't know if companies are still doing drug testing or not. Obviously, you can't do a virtual drug test.
Sure.
But you can look at criminal records. You can look at a whole bunch of things. Is that something that you see valuable? Is that something you guys can do as well, as reach into the public side of things as well? I mean,
yeah, if you think about just the profile, the internet profile on yourself, or if I think about the internet profile on myself, right? I have a LinkedIn profile. I'm on Reddit. I'm on GitHub, and you start to look at all the different pieces of information that are available. What skills do I have? I have some work history in the field of cryptography, but I probably shouldn't be developing any crypto algorithms. I definitely shouldn't be developing any kernel level, Linux drivers, for example. So I might be able to look at that and say, boy, this person is kind of out of their element, and the quality of the code that they write is pretty low, and they're associated with this malicious website over here. And you start to build up and say, I want to look at what they're writing,
right? I got you.
Make sure. I can't review 30 million lines of Linux kernel code, but I could look at their, a dozen lines that they've contributed just make sure that everything looks okay and say, yeah, thumbs up. We had a little flag here, but we're going to swipe that away because it looks like it's okay. We've had eyes on it.
So you're not just looking at my contributions. You're also you're doing a background check on open source developers.
You could say that, or in for the purposes of finding those developers who would intend to, create malicious harm.
Well, yeah, companies do that. Companies do that when they hire someone, right? You have to.
Yeah. And right, I've had background checks done on me, and rightly so. And if the first thing that I did was step in the door of a company that now trusts me because of that background check and the references that they've talked to, and I start pulling in code from all over the place, and they don't know where that came from. I wasn't the one that wrote it. Somebody else did.
Yeah.
And they have no idea where it's coming from.
No, that's somewhat scary. So if people want to find out more about this whole concept, I love trusting open source contributors. That just kind of, where do they find out more information? And where can they contact you to engage if this is a concern of theirs?
Yeah, we're on darkskytechnology.com is our homepage. We spend a lot of time on LinkedIn. That's a great way to, direct message us. If you search Dark Sky Technology, you'll find us, and you can send us a message or interact with our content. We're really big on kind of spreading the word and just opening up the things that we've learned about cybersecurity and reverse engineering over the past 20 years, and sharing it with the community, and trying to help bring awareness and understanding that open source is a phenomenally great thing that's just done amazing. It's done amazing things in technology space, but we shouldn't just blindly trust it and grab it and put it into our systems, especially for those really critical systems that are either supporting our warfighter, or maybe responsible for our,
healthcare, financial.
Background.
I mean, the list is long.
Right.
Yeah.
Right.
So,
so those would be two great places. Yeah.
Yeah. Michael, thank you for coming on the show. This is exciting. This is interesting to me. Right. Very, very interesting topic.
It's very interesting. It's so much fun to be engaged at, kind of at the root level of trust, right? Because if we can build that trust from the ground up, then we can finally get to systems that we trust, and we can send out knowing that they're going to do what they're meant to do, and not be compromised by somebody who has different intentions for us.
Yeah, absolutely. Again, Michael, thanks for coming on the show.
Thanks for having me.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.